That's important because a large language model at its core is just a really long list of numbers or weights. A small model might have a few billion, and a large model might have hundreds of billions. So a 70 billion parameter model in 16-bit precision needs about 140 gigabytes in memory just to load. And it's not doing anything, it's just sitting there. So in order to make LLMs accessible to more people, we need to drop the precision down slightly. And one of the ways you can do that is through quantization. If you go from 16 bits to 8-bit, the model halves in size. If you go down to 4 bits, you've shrunk it by a factor of 4. So a 140 gigabyte model can now fit in 35 gigabytes, and suddenly it can run on a high-end Mac. That's the technical unlock, and it's the difference between needing a multi-million-dollar server rack and a model that is small enough to can fit to run on your desk. But of course, nothing comes for free. The model becomes slightly less accurate, it makes a few more mistakes, and it might be a bit less coherent on tricky problems. Going down from 16-bit to 8-bit, usually you can't measure the difference. Once you go down from 8 bits to 4 bits, that's where things really start to break. So the practical sweet spot for most use cases right now is somewhere around 8-bit. It's big enough to matter, but small enough that the quality loss you can live with.